Many people ask themselves, when we split things up into services and components, why do we do that? And one of the most important reasons why you do not want to have spaghetti code is automated testing. What do you think? Why is automated testing a thing? Why do people spend time writing automated tests? Exactly. Manual tests are simply boring. Manually testing is toil. It is something that nobody wants to do. And typically, we are very poor testers as developers. Good developers are rarely good testers. And therefore, we often fix things or add features, and by adding features, we break something. Have you ever done that? Adding a functionality to software and suddenly something else is broken? Everybody does it, all the time. And by adding automated tests, you can run your tests 1,000 times a day. And it will not take you a single second because they are done automatically. Let's try the most simple test that we can think of. Please add here, inside of level 4, let's add a new file, and we are going to call it board.service.spec.ts. Do you see this nice little laboratory icon here? This indicates a test. A little bit of background information. By default, Angular uses a testing suite that is called Jasmine, like the tea or the flower. And it uses a so-called test runner, which is called Karma, like in bad karma. Karma and Jasmine are the things that are built in as of today. There are, I would say, more modern or more trendy test systems, like for instance Jest. Jest is very widely used in JavaScript development. We will stick to Jasmine and Karma not because they are better than Jest, but they come with Angular out of the box. So you do not need to do anything. They are just enabled, they are just there. If you want to switch to Jest, you have to dive deep into Angular's configuration logic, and that is a lot of work. So in this course, at least in the next few months, we are going to go for Jasmine and Karma. If you really want to use Angular for your final year project, for instance, I would consider, if I were you, to switch from Jasmine and Karma to Jest. Or any other testing suite which is a little bit more modern. But Jest is really a very good solution. In my company, we do a lot of Angular development. This is our most important UI framework. And we also use mainly Jasmine and Karma because of historical reasons. But if I start a new Angular project professionally, I typically switch to Jest. Just follow along. It's pretty simple. So we built the first professional unit test. Describe BoardService. Then we specify a Lambda function for implementing our test. Looks like that. And here we say it can compare two numbers and then we write expect 1 to be 1. Congratulations, you have just written your first unit test. It makes no sense, granted, but it's a good first try. We describe the tests for the board service, and we test whether the board service, it, can compare two numbers. You can read the descriptions of this test file. We describe the tests for the board service. We ensure that it can compare two numbers. Then you do something, and then you write so-called expectations. Expect the number 1 to be 1. So let's run this test. Please go into your console and just say npm test. This will now kick off Karma. Karma is the test runner. Technically, it's a web server, and it will allow you to access your tests using the port 9876. A browser should open automatically. You should see Karma. Oh yeah. In my case, there is a bug. Some of you have, some of you haven't. What I forgot is that on the top level, you see, there is still an old spec file that we didn't maintain, so I have to delete that one. I didn't delete the app component spec.ts. That was my mistake. Let's delete this one. And then let's take a look at the karma again. And now we have good karma. See? Everything is green. And we have an automated test. It is meaningless, but it is a test. And do you know how real-life web development should look like? In real-life web development, you should have multiple monitors. On one monitor, I simulated here, on one monitor you have your Visual Studio Code. And on the other monitor, you continuously have your Karma and Jasmine running. And then you maybe change something in your code. Just take a look at my screen. I changed the 1 to a 2 and therefore breaking the code. I don't touch the keyboard at all. It will automatically rerun Karma, rerun the Jasmine tests, and I will immediately see on my second monitor, oh, I just broke something. It will stop me. It is a continuous quality assurance process that whatever I do verifies the entire application. So I immediately see, oh, I broke something. Let's fix it again. I change this one back to 1. I don't do anything. It automatically runs. And this does not just work on one PC. You could have your tablet, for instance, in the same network accessing just this web server. You see? It's just a web server. Let me demonstrate what I mean. I can open maybe a second browser. Maybe let's do that one. I have up here Chrome, and down here I have Edge. And I would like to make sure that my application works in Chrome and Edge. So what I'm going to do is I'm going to open Jasmine and Karma in both browsers, you see? And if I change something, all the tests are run in all browsers. So if you want to build an app with Angular that works on a smartphone, on a tablet, on Safari, on Chrome, and in Firefox, what you typically end up is having multiple devices on your desk, a mobile phone, an iOS device, Safari browser, whatever. You always, all devices, you access Karma, and then when you type something, all your devices magically refresh automatically, and you always see whether everything is okay. And this automatically refreshing everything behind the scenes, this is the job of Karma. Karma is running all the tests, while Jasmine is the API of writing the tests. So let's write our first meaningful test. I will keep it running, and I will also keep this test. It's fine. Let's keep this test. Please just follow along, and maybe you will automatically understand what I'm doing here. It can set pieces on the board. So I want to test the set method and see whether the set method does what it's supposed to do. So let's create a board. Const board, new board service. Got it. Let's call the set method on it. Board set 0, 0. So we set something on the left upper corner. And if we set something, then the board content must have been changed, right? Good. Expect board content 0, 0 to be 1, because this is the first player. And you know what? Let's set another cell, maybe the cell 1, 0, and then change that one to 1 and that one to 2, because then it should be that the second cell is now the player 2, captured by the player 2. And this is now a meaningful test. We test a lot of things here. We test the functionality of the set method. We test whether the set method automatically increments the current player index from 1 to 2, because now we check for the second set whether the second set changes the occupation of the second cell to 2. And if we check that in our Karma output, everything is good. Everything is green. Let me demonstrate why this is important. You don't need to follow along. Just check it out what I do. I go into BoardService, and here in the set method, for whatever reason, I do a typo here. See? For whatever reason, I change that to 1. I just make a mistake. And you see, it automatically breaks. And it tells me this is a problem. So I have a kind of safety net here that immediately shows me what I have done. So let's switch that back, and everything should be fine again. If you write spaghetti code, where everything is kind of mixed together with the output and the logic and so on, it becomes very hard to build small, meaningful tests. It's still possible, but it's very hard. If you structure your code into multiple separated units, into units of logic that belong together, then you can test these units. And it's much easier to test something small than test everything all together. Have you ever had this problem that you sit down for hours and you write a lot of code, and after hours, for the first time, you try what you have built, and it doesn't work, and you have no idea where to start with finding the error? Has anybody ever done that? No, you have never done that. Of course, not you. I did that quite often. So what I do typically is I always try to change or add small things. Because when I add only a small thing, then I can easily try this thing out. And if it works, I add the next tiny thing. And immediately I try it out. And I add the next tiny thing. Because then I always have tiny steps, baby steps. And it's very easy to find the problem, the source of the problem if I make a mistake. Because I only changed a little bit. And it's the same here. By structuring your application into multiple units, you can easily test each tiny functionality on its own. And if something breaks, you get an immediate idea what is wrong. If you write spaghetti code, then you have no idea where the problem is. Somewhere in your big ball of spaghetti, but no idea where. If you write it really nice, then the unit test will tell you the problem is in noodle 17. And you can immediately take a look at noodle 17, and there you will spot the problem. Get the idea, right? Good. Let's write the next test. The next test is a test where I would like you to try that. The specification is make sure that multiple set operations on the same cell are ignored. That means if we call set on cell 00 and we call immediately set on cell 00 again, the second call has to be ignored. That means the player must not be changed and the content of the cell must not change. If we set cell 00, it should be player 1. And if I set it immediately again, it should not turn to player 2. And it should still be the player's 2 turn because we simply ignore it. Try to write the test, please. Ignores duplicate calls to set for the same cell. Okay. Good. That is okay. Say const board equals new board service. This one. Then we simply call two set operations, board set 00. Now it has woken up again. Board set, and you see now GitHub Copilot does its job because it automatically suggests me that board 00 should be 1. The second one should be ignored. Very good. And if I take a look, it's automatically green. Nice, isn't it? I would like to give you a tip. Sometimes when you do some coding, it might happen that you intentionally break functionality. Maybe you want to really refactor part of your application, and you know that for some hours you're going to break a lot of things. And then it's kind of inconvenient if Karma and Jasmine are continuously shouting at you, telling you that you messed up. If you would like to ignore temporarily, and I emphasize that, if you would like to temporarily ignore tests, you can write an X before it. Exclude. And if you do that, you will see, as you can see it here, that this is now, see, temporarily disabled. But please do not permanently disable tests. Remove the X once you are done with refactoring. By the way, this X can also be added to the entire describe here. So if I say X describe, it will automatically disable all the tests in the entire describe section. So this is sometimes really useful if you perform larger refactorings in your code. Then I have another example for you. Let's practice it. Make sure that the winner is correctly identified. It is so good when a row is filled. And while you are at it, guess what the next test will be. Make sure that the winner is correctly identified when a column is filled. Guess what the next test will be when a diagonal is filled. And this is what I want to do, or what I want from you for the rest of this 15 minutes that we have in this course. Write these 3 tests. Spend the rest of the lesson for writing these 3 tests. Try to come up with a nice solution. Tell me when you are done with one of them. I can take a look. And if you want, you can always, not now, try it on your own, but afterwards, you can always take a look at my GitHub repository, because there I have some sample solutions that you can look up.